Hope you're having a great long weekend. I know I am. If you're in Miss Dooley's class, these are the instructions for your new page of Cornell Notes. If you're in Miss Diaz's class, this might be a different page number, but the title and the essential question are probably pretty similar. So when we measure, there are different parts to what we communicate. We obviously have the number part, okay, which we always write. But what's more important to a scientist is which unit of measurement are you using, okay? And so we say no naked numbers because you can't just say, how tall are you? I'm 20. You're 20 what? 20 feet, 20 hands, 20 inches, 20 centimeters. We don't know what you're talking about, so you always need to include units. Some people call this the dimension that you're measuring, like mass or weight or time, and then some people call these the units of measure. But either way, there are very rare occasions where a number that we use in chemistry doesn't have a unit, but most of the time they do. So today's topic is called significant figures. When you were in 6th, 7th, 8th grade, you guys use rulers like this all the time. And we said, okay, hey, measure this. And you would say, oh, that's 7. Or, oh, maybe it's close to 7.5. Maybe even said it's 7.2. But what we're going to teach you in a few days is how to estimate this last digit. And so a significant figure is everything that is known or marked on an instrument plus this one estimated digit. And this is what we call being significant. Significant figures are the number of digits that can be accurately measured plus that first uncertain or estimated digit. For example, if we were measuring something and you said it is 7.2 centimeters versus 7.21 centimeters, this digit is more precise than this digit. And so we always want you to have an estimate on the end of your digit that tells us that you were trying to be precise. And we will talk much more about that on Tuesday in class. So we have some rules that come with whether a number is significant, whether it's a place value note holder, or whether it is just a number that is just not important to us when we're communicating our measurements. So rule number 1 that you need to write down for sure is all non-zero numbers are significant. And so this includes any single digit that's a 1, 2, 3, 4, 5, 6, 7, 8, or 9. And so when we are looking at measurements that include these numbers, we always say that they are significant. For example, when you look at this first number, 3.89, since the 3, the 8, and the 9 are all 1 through 9 numbers, we say that they are all significant. We measured each one of those places. None of those are placeholders. And so we say that that is 3 significant figures. I love abbreviations, so I abbreviate this as SF for Sig Figs. In high school, I actually learned it as significant digits, so I would say SD for Sig Digs. So I'm going to interchange Sig Figs and Sig Digs, and I can't help it. It's just trying to retrain my brain to say figures instead of digits. So if I look at this second example, 938.3, since all of them are a 1 through 9 number, that means that I measured each one of those places on a measurement tool, and so therefore that we would call that 4 significant figures. This will make a lot more sense as the rules go on. Rule number 2 talks about these zeros. We left those out of rule number 1. You didn't know it, but there are lots of types of zeros. So we call this first rule the sandwich rule. When you make a sandwich, you put a bunch of stuff between the bread. Well, when we make a sandwich with Sig Figs, we put a bunch of 1 through 9 numbers on the outside of some zeros. The zeros get sandwiched between. Anything that gets sandwiched between a 1 through 9 is always significant. So in the number down here, 202, we know that the 2's are significant because they're a 1 through 9 number. But because this 0, however, is sandwiched between this 2 and this 2, we're going to count him as also being significant by default. And so we count all 3 of those as part of our measurement, and we say that that is 3 significant figures. So again, if we look at this in a little bit different of way, we know the 6 and 7 are significant because they are a 1 through 9 number. The 4 and the 5 are also significant because they're a 1 through 9 number. These are all sandwich zeros. And when I say sandwich, they're sandwiched between the 7 and the 4. They get sandwiched between 2 significant numbers. So they automatically count. So in this number, we would say we had 8 significant figures. Down below, when we look at this number, the 1 and the 5 are automatically significant. The 9 and the 8 are automatically significant. These are called sandwich zeros. They are sandwiched between the 5 and 9, so they are significant. We're not going to talk about this guy right now. But so therefore we say that this guy has 6 significant figures. When we look at rule number 3 changes a little bit. So now we're talking about another kind of zero called a leading zero. Now, be very cautious. A leading zero is a 0 before a 1 through 9 number. I never ever mentioned the word decimal. I don't care where the 0 is in regards to a decimal. I just care if the 0 is in front of a 1 through 9 number. It is not significant. Never, ever, ever, ever will a leading 0 be significant. Let me show you what I mean. In this first example, we have 0.91. This 0 is in front of the 9. So we say that he is leading the 9. The 9, of course, is significant due to Rule 1. The 1 is also significant. So the 0 is merely what we call a placeholder. It wouldn't be a bad idea to write the word placeholder above this 0. Now in this case, some teachers say, no, you don't have to write the 0 in front of a decimal. I was always taught that I had to. My teacher wanted to know that the 0 was just a placeholder, and she wanted to call our attention to the decimal. This is an optional 0. You don't have to write it. So, in other words, the 9 and the 1 are both significant. The 0 is a placeholder. So there are only 2 significant figures in this number. Now take a look at my next example. It gets a little different. So the 8 and the 9 are of course significant. This 0 in front of the decimal is definitely a placeholder. And again, we may or may not write it, it doesn't matter. But these 2 zeros, people get a little bit confused. We also call these guys leading zeros. And they're leading because they're leading the number 8. They are not, I repeat, not leading the decimal. I don't care about the decimal. All I care is that these zeros are before this 8. So all 3 of these zeros for significance do not count. Do I have to write them? And the answer is yes. And the reason I have to write them is because they are also placeholders. And so since they're placeholders, I have to write them to hold the place of the 8. But they are not part of my measurement. So when I'm saying what part did I actually use to measure, I only use the 8 and the 9 to show whoever I'm communicating to what my number represents. This is only 2 significant figures. Those zeros are placeholders. Rule 4 is probably the craziest. We call these guys trailing zeros. If you are trailing the leader, you're behind the leader. And so the trailing zeros are behind a 1 through 9 number. They are after another significant figure. And this if is huge. A trailing zero is significant if there is a decimal place in the number. Notice I didn't say where the decimal was located because, frankly, I don't care. All I care about is if there is a decimal. Don't worry, we have tons of examples. So in 202.0, we already know that the 2's are significant. Hopefully you remember that this 0 is sandwiched between the 2's. So it's a sandwich 0. These zeros, however, are after the 2, not after the decimal, they're after the 2. So since they are after the 2, I ask myself the question, is there a decimal place? And when the answer is yes, I say yes, they are significant. And so the answer is 5. Now take a look at these examples. Here's the number 1,000. The 1 is obviously significant, but these zeros, we have to say what kind of zeros are these. And don't get confused by this decimal. These are not leading zeros. People want to say, oh, these are leading, they're leading the decimal. No, no, no. These are trailing zeros. They are after the 1. They are after the 1. So since they're after the 1, you have to ask yourself, is there a decimal? Yes. So are they significant? Yes. So all 3 of those zeros count. The answer is 4. Now, if I had written the number this way, 1,000, the 1 is significant. But now, these zeros, we say, is there a decimal? And when we say no, all of a sudden, these zeros are no longer significant. And the answer would be 1 Sig Fig. Now, am I saying that I ignore these zeros? No. In this instance, I need these zeros as placeholders, but up here I had a decimal, and so they are significant. The numbers are very similar, but think about it like your bank account. If somebody said, how much money is in your bank account? And you're like, oh, I have $1,000. Well, do you really have exactly 1,000, or do you have $993.42? If you have $993.42, you're going to say, I have $1,000. You rounded your number up. There's no decimal. So there is 1 measured place and 3 placeholders or rounded places. If somebody handed you 10 $100 bills and somebody said, how much money do you have? And you say, I have $1,000. This decimal right here indicates I have exactly $1,000. So each one of these places here is significant. And so we're saying we measured or counted all of those spots. So this is a better number because of the decimal. This is a rounded number because it's missing one. So if we keep going with our examples, the number 45,000, the 4 is significant, the 5 is significant. Then you ask yourself, is there a decimal? No. So do those zeros count as significant? No. So the answer is 2. Do I have to write them? Absolutely. Those zeros are holding the place of the 4 and 5. Meaning, if I didn't write them, I would say, oh, I had $45. No way, I didn't have $45. I had 45 grand. What'd you do with my money? And so we have to have those zeros there to hold the place of the 4 and the 5. But we're just saying that these numbers are rounded, so they're not significant. Rounded numbers are placeholders. They are not significant. Now take a look at our next example. 450.000. The 4 and the 5 are significant. All of these zeros are the same type. These are trailing zeros. Is there a decimal? Yes. So do they count? Yes, 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 and yes. So that is a 6. You're telling the reader, I measured all 4 of those places on my measurement tool. They are all significant. Love this last example. Gave you a little bit of everything. What kind of zero is this guy? This is a leading zero. Leading zeros are not significant. People get confused here. These 2 zeros are also leading. They are not trailing. They are leading the 4. The 4 and the 5 are significant, and so is this 5. So they are leading the 4, so they are not significant. They are placeholders. These zeros here are sandwiches, so they are significant. These are trailing zeros. What are they trailing? They're trailing the 5. Is there a decimal? Yes. So are they significant? Yes. And so these zeros also count. So the answer to this guy is 7. If we wanted to practice real quick, 1, 2, 3. Sandwiches, that's a 6. 1, 2. Trailing, is there a decimal? No, they don't count. It's a 2. So when the answer is no decimal, no count. These are leading. No, no, no. Yes, yes. These are trailing. Is there a decimal? Yes. So do they count? Yes. The answer is 4. Rule 5, you don't have to write it in your notes, but when we count things like people or where we say conversion factors like, hey, 60 minutes or an hour, we're not going to use this and say, oh, it only had one significant digit. We know that these equalities are true. We don't care. You either have 24 people or you don't. When we count, there's an undefined or unlimited amount of significant figures, and we'll talk more about that next week. Rounding is a lot like what we did in math, except now instead of saying, hey, round to the nearest 100, round to the nearest 1,000, we're going to round to the nearest Sig Fig. So in this example, they say round this number 56.312 to 4 significant figures. So in my brain, this is what I do. I start on the left and I start underlining until I get to the 4th digit. There it is. So I've got 1, 2, 3, 4. The 4th one, looks to the fifth and says, what does he do? Round up or stay the same? And you should know your math rules. 5 and up goes up. 0 through 4 stays the same. So he stays the same. My answer is 56.31. Pretty straightforward, but instead of saying, we're going to round this to the nearest hundredth, now we're saying we only can have 4 significant figures in our answer. Let's try some harder ones. In this example here, they only wanted 2 significant figures, so I underlined the first 2 numbers. Well, the first 2 numbers are not significant. These are leading zeros. So I keep going. This is a leading 0. I keep going. A 1 counts. A 7 counts. So all of a sudden, I'm up to 2 significant figures and some zeros that don't count. So when they say, hey, round this number to 2 sig figs, this is what they mean. 0.001. The 7 has to look to the other 7, and since it's above 5, it has to round up to 8. Now, some of you may be wondering, you just crossed out those zeros, and they only wanted 2. So why didn't you just write 18? Well, if you look at this number, I didn't run a distance of 18 meters. I only ran a distance of 0.0018. Now, I wrote these 3 zeros because they were placeholders. I have to write them even though they don't count as significant. So I still have to include them to hold the place of that 1 and that 8. But they are not significant. So in this number, 0.0018, there are only 2 significant digits. 1, 2. And the zeros are my placeholders. The next example gets a little bit tricky. They want 2 sig figs, so I underline 1, 2. The 7 looks to the 9 and rounds up to 88. Now let's think about place value. How much money was this 8? That was $8,000. How much is this? This is $80. So I can't chop my number off. I can only have 2 sig figs, which I totally do. But I need the 8 to keep its place. So I have to come on to the end of this number and add zeros until the 8 stays in the same place value as its original position. If this was 8,000, this also has to be 8,000. So I have 8,800 meters. When we calculate, we're going to talk a lot about this. It's not going to make a lot of sense now, but your answer cannot be better than your measurements. And we're going to get to that, and I promise it'll make a lot more sense this week, but take a look. When we multiply and divide, the rule is different than addition and subtraction. Your answer has to be rounded to the same number of significant figures as your least precise measurement in the calculation. I would write this down, and then I would write a few examples in your notes. We have 4.56 times 1.4 meters. If we put that into a calculator, we get 6.384 meters times meters is meters squared. Now let's take a look. You're measuring in a lab. This measurement that you handed me has 1, 2, 3 significant figures. This number that you handed me only has 1, 2 significant figures. Well, if you look at your answer that you gave at the end of the lab, you're telling me that you have 1, 2, 3, 4 significant figures. Your answer is more significant than your measurement, which cannot be possible. So you have to look at this and say, this one has 3, this one has 2, which is less this one. Your answer has to match the significance of your least significant measurement. So instead of saying 6.384, I can't have 4 sig figs, I can only have 2. So I underline the first 2, the 6.3, the 3 looks to the 8, and rounds up. So it ends up being 6.4 meters squared. This is the best answer. If you're going to give me a rounded measurement, I'm going to give you a rounded answer. If you want a really awesome, precise answer, you need to give me a really precise measurement, and you didn't. And so the better your measurements are in lab, the better your answers can be. So in this next example, 5 times 11, I know you know this in your head. So if we did 5 times 11 centimeters, we would get 55 centimeters squared. Now I'm about to freak you out. Ready? 5 centimeters. How many sig figs is that? It's 1. From a measurement standpoint, that is a terrible measurement. Very rounded. You could have given me something awesome like 5.02, 5.23, 5.89, but you gave me 5. So I have no idea how important that number is to you. So it looks pretty terrible. The next number you gave me was 11. 11 is a little bit better of a measurement. It has 2 significant figures. So you got better on that one, but it was a fluke because it just happened to be a double-digit number. So when you give me this answer, 55 centimeters squared, that is also 2 significant figures. Well, the rule says your answer can't be better than your worst measurement. Your worst measurement only had 1 significant figure. You always go with the lowest number. So since my measurement had 1, my answer had to be 1. So that means that this changes into 60 centimeters squared. So if this doesn't freak you out, let me put this into perspective. 5 times 11 equals 60 in chemistry. If that didn't freak you out, this will. Addition and subtraction is totally different. Now your answer has to match your least precise place value. Least precise place value. So when I look at this number, 550, I say, okay, where are my significant figures? The 5 is significant. The 5 is significant. The 0 is not. The 1 is significant. The 3 is significant. And so I say, okay, in 550, I kind of start on the right and I draw a line until I hit a significant figure, which is this 5. I do the same thing in the 13. I draw a line until I hit a significant figure, which is the 3. Well, if you go back to 4th grade, the 5 is in the tens spot, and the 3 is in the ones spot. The further to the left that you go, that is where you're going to find your less precise place value. So when I'm looking between the 5 and the 3, whoever is on the left is the least precise. So that is this guy, this 5. So in my calculator, if I typed in 550 plus 13, I obviously would get 563. And in math, that is a beautiful answer, but in chemistry, it's not correct because the 3 is too precise. And so we have to look at the tens place, and we have to tell ourselves that the 6 is in the tens place, and so I have to round 563 to the nearest tens, and so that just so happens to be 560. So now my answer matches my least significant place value of the tens. Let me show you a different one. Same rule as subtraction with addition. 60 minus 5 obviously is 55. I know that we know this. Now let's look at significant figures. I draw a line to the right and say, nope, that's a placeholder. So I keep going to the 6. It's in the tens place. I draw a line from the right to the 5. It's in the ones place, and it is significant. So who is less significant or less precise or less important? The tens or the ones? The tens is less precise. Whoever is the leftmost wins. The tens is to the left more than the ones. So because of that, I have to round my 55 to the nearest tens. When you round 55 to the closest 10, you get 60. Does this freak you out? 60 minus 5 is 60 in chemistry. Take a deep breath. It will be okay. We will do a few more multiplication and division and addition and subtraction when you get to class on Tuesday. Stumble through this. My advice is put all of the homework numbers into your calculator, press enter. Write it all down on the blank. Then draw your lines and underline your significant figures. Once you get those written down, then you can start to round. Let me show you what I mean. If one of the choices was 2.54 times 1.6 equals, the answer would be 4.064. I'm going to go ahead and write all of that on my answer blank. Then I'm going to come back and I'm going to analyze. And I'm going to say, this is multiplication. I'm looking for the lowest number of Sig Figs. So I look at 2.54 and I say this guy's got 3. I look at 1.6 and say this guy's got 2. The lowest number of Sig Figs is indeed 2. So my answer can only have 2. So I come over here and I underline the first 2, 4.0, 0, looks to the 6, and rounds up to 4.1. So there's my multiply and divide rule. Well, maybe I gave you, let's add them. 2.54 plus 1.6 equals, we so happen to get 4.14. And so the adding rule is looking at place value. You draw a line to the left until you hit a sig fig. Draw a line to the left until you hit a sig fig. Then analyze the place, the 4, and then the 100th place. The 6 is in the 10th place. Which place is less significant or less precise? The one that is most on the left. So out of the 100th and the 10th is the least precise. So I come over to my answer. I underline the 10th location. He looks next door and says he stays the same. And so I round my answer to 4.1. This is the weirdest thing ever. I made up this example right when I made this slide, and both answers absolutely match. That never happens. I hope you get the point. We will help you. If anything, put it in your calculator, write down the calculator answer. Come see us Tuesday morning. We will be there by 7 a.m. We would love to help you. Google it. Ask some friends. You're awesome. Don't give up. See you Tuesday.